Okay, so in this example, what I'm going to do is to show you how we can create a smart contract to create a scrambled alphabet challenge generator. So with a scrambled alphabet, basically we take the alphabet and we scramble it up so that we can map our normal alphabet into the scrambled alphabet. So for example, an A might become a Z, a B might become a D, and so on. So what we'll do is that we'll create our smart contract in Solidity, then we'll compile it, test it, and then hopefully we'll be able to implement this or deploy it onto the Robston test network. Okay, so the way that a smart contract works is that we have a number of functions. Those functions can be public so that we can interact with them, or they can be private or internal. So in this case we have two internal functions here. This one is a random number generator. It's not a perfect one, but it at least gives some randomization every time we call up the smart contract, and this will return back the time that the smart contract is run. This isn't a truly random function because it is predictable if someone knows when the smart contract was run. The other one that we have here is a to lower, and that converts uppercase letters into lowercase. Okay, so here's the function here. What we've got is a number of phrases, and we'll take 5 main phrases into a string array, and then we'll pick one of those whenever the smart contract is run. We don't know which one, we'll try and pick one at random. And then what we do is we set up a string array with all the alphabets, characters. And what we'll do with this is that we'll shuffle each of the characters with another random character to be able to get a shuffle for the mapping of the alphabet, the cipher alphabet. Then once we have that, we'll be taking each of the characters and remapping them to the shuffled alphabet. So the first element here does the shuffling. We take a random number for each of the letters of the alphabet. We go from A, B, C, and so on. So we'll take A and we might swap it with F. So we move A out into temporary place, we move F into A, and then we take the temporary place and put it into the position where F is. So that's what that does here. Takes the letter out, in this case it would be an A, and then puts the random letter that we're going to select, puts it into that position, and then puts the original letter back in the position that we've just moved from. And this would allow us to be able to swap the characters over and give them a shuffle. The next thing that we do, we can build them back into a string for our cipher mapping by taking each character at a time, and then we can concatenate our string and build it up with each of the characters so that we can actually display it out later. Okay, we'll do that here. And then what we'll do is we're going to print a message. So the return from this function is RTN. So we'll build up the string, find the message from, and this little bit of code here will go through each of the letter in the phrase that we're going to select. And we picked a random phrase here, convert it to lowercase, and then we'll go through each letter, finding the place in the alphabet that the character is. So for example, an E would be 5, a D would be 4, and so on. So for that we take the letter and subtract 97 from it. 97 is an A, so when we do this with an A, for example, an A character, we get 0. If it's a B, we get 1, and so on. So that will give us the position of the character, and then we can remap them into our cipher character as we have here from our scrambled values. This is a byte array, so we can access each character one at a time. And that will remap it, and we can build the string back up for the ciphertext. Then we're just going to display that here with the cipher, and then return it back. Okay, so everything's fine here. So we'll just try and compile that, and it compiles great. We get a little tick over here. Everything's good. So now what we'll do is we'll start up our Ganache for our local blockchain. You can see it creates a number of accounts for us, and they've already got some Ether in there. We're only really going to be using one account here, and that will be used to be able to mine the smart contract. Okay, so we'll just have a little look, and what we'll do is we'll just get it set up. So we want to be on web provider 3. So we'll just check that's 854, and that's a local address, so it should connect to the service, and it has. And then it takes the account, the primary account, which is 4AC, and that's the right one here. Okay, so over here what we should see is the Ether here will go down as the miners pick up the contract and mine it. So we'll just deploy that, and that's what you see here. We've lost 0.02 Ether because the miners have mined that smart contract, and it's been recorded down here too. Okay, so we don't need any more gas for this because we're not going to change the state of any of the variables or the data within the contract. So here it's here, so we can now test it. So this is the only public method, so we'll give it a go, and there is the code there. Okay, so what you should be able to see is that there's the cipher here, and there is the mapping that we've got. So there's the alphabetic mapping, and that's the mapping that we have for the code for the scrambled alphabet. Okay, so here is the return back from the function. Okay, so we'll just examine that. So just make the text a little bit larger here. We'll just make it Courier font. Okay, so here is the cipher that we've got, and here's the mapping. So a Y is a W. So the first part is a W. A C is an I. An M is a T, so we can see. And a D is an H. So we can see the word is with. So straight away we can actually see that the cipher has been fairly successful in its creation. And if we just have a quick look, it's likely that we have this phrase here. Okay, so it looks as if it's working fine from there. So now what we'll do, if we're happy with that, we'll now deploy that onto the test network. Okay, so for that we go for injected Web3, and we will pull up our wallet. Okay, so here's the wallet here. We'll just check that the ID is correct. That's my public ID for this wallet. It's not real Ether, we're just deploying it onto the test network. So we'll go ahead, and what we'll do is just check that we've got the right contract. We then deploy this. Okay. Okay, so here is our contract that we've created. What we need to do first is to be able to verify it. So it's a single file, and now we need to select the compiler version. So I think we've used 8.087. That's correct, and then we'll check the license. And we'll go with that. And then we'll paste in our code. And we're not a robot, and we should be able to verify that now. So it can take up to 30 seconds for this to happen. So we've just got to wait a little minute while it it checks the code against the Solidity code that we've entered here. Okay, and that's worked. That's great. So there's the bytecode. If you're interested, that's what our smart contract looks like. But we'll go back here just so that we can test it. Okay, so nothing is secret really. There's all our code there. We can now test it to see if it's working. So let's press the button here, and there we go. There's our cipher, and we'll give that one a little try just to see that that's working okay. Okay, we'll just make that a bit bigger again. Make it courier. Okay, so here's the mapping, and we have a J. So a J corresponds to a T, and a G corresponds to an H. I know what this is already, and then M corresponds to an E. So the word is the. Okay, so it looks like this is working too. So we can reset and we can try another one. And then each time it should give us a different cipher. So you can see here it's a different phrase because it's only got 2 characters there. Can reset again, and there we go. Okay, so it doesn't cost me any gas at all to be able to run this smart contract, but it did to deploy it. Okay, thank you.